Oh my god. Oh my god. Like, it real life stopped my stream. Y'all, I'm so sorry. It real life stopped my stream. I am so sorry. Oops. Don't kill me. Don't kill me. I'm so sorry. It stopped my stream. I don't even know what happened. Okay. Well, moving on. Let's study. Alright, sorry about that. To everybody that was in here and like, oh, it's so bad. That was so bad. Okay. Blocking the electron transfer by any one of these inhibitors stops electron flow because reaction. Okay. Free energy released during electron transport. Okay. Wait, where was that? Yes, free energy during electron transport train. Excuse me. I am so sorry that it stopped the stream. That sucks. Y'all, ignore that. Literally ignore that. Uh-oh. Uh-oh. Why does everybody want to call? Everybody wants to call me for something. Goodness. Standard reduction potential. Excuse me. Oh. Then it goes into the phosphorylation and that goes into oxidative phosphorylation. Okay. I need a video on electron transport chain. Cause what? Like, I feel like that was a lot. Video and audio. Biochemistry. Electron transport chain.
The electron transport chain represents the final common pathway in aerobic metabolism. It takes place on the inner mitochondrial membrane, which consists of protein complexes and electron carriers. Inside the matrix of the mitochondrion, 2 electrons are transferred from NADH to the protein complex NADH dehydrogenase. At the same time, 2 hydrogen atoms, one for each electron, are transferred across the membrane into the intermembrane space. The electrons are moved from the NADH dehydrogenase complex to an electron carrier, coenzyme Q, which transfers them to the cytochrome BC1 complex. One at a time, the electrons then move to the cytochrome C oxidase complex via another electron carrier, cytochrome C. Simultaneously, hydrogen atoms are pumped to the outside. Once 4 electrons have been transferred to the next complex, cytochrome oxidase, they interact with oxygen molecules and hydrogen molecules. The electrons and hydrogen and oxygen molecules are used to form water, while the other hydrogen molecules are pumped across the membrane. After this series of hydrogen pumping, a gradient is created. Its energy is used by ATP synthase to form ATP from ADP and phosphate. This is called oxidate phosphorylation.
Okay. My thing is, why did I just read almost the whole chapter for you to just tell me that? Like, all right. Quick review. We're going to the whiteboard. I need to change some things around so y'all can see. Just a little adjusting. I don't know. I don't even know how that looks, if we're being completely honest. We're just gonna go with it. Okay. Where's my here it is. Okay, let's see. Let's draw this out a little bit. No, I need something like fully different. Where's my black? I don't. Okay. So. This is our mito. Right? This is, I'm sorry, where's all of this happening? I gotta go back to it. Okay. This is intermembrane. This is the matrix right here. M for matrix. Not M for mito. M for matrix. Oh, y'all can't even see the drawing. Ugh. I'm sorry, TikTok. You have to be moved. Sorry. Put y'all over here or something like that. Y'all can't even see for real. Okay, there we go. We have our matrix. Intermembrane matrix. Okay? Electron transport chain is here. Make these little boxes. Okay, these are our complex. We got 1, 2, 3, and 4. Okay, we have all of 45 seconds until our first 50 minutes are up. I apologize. We will be going over these 50. We had a mishap. Alright, so this right here, that C, that's cytochrome C. Okay? Y'all can't see nothing, but I'll put you there. Okay, this C is cytochrome C. Important, because it's used to transfer stuff. What stuff? We're getting there. So, let me just review. I should probably have a different color. Well, there aren't really very much different colors. I don't know where all my expos are at. Time for a break. Should we take our break? I think we should. All right. Let's take our break. All right. We'll take the break. Yeah, we're on break, and I'm like I'm kind of understanding it. I'm kind of understanding it. So we're gonna see. Um, we're almost there. All right. It is officially time to study again. So back to what I was thinking. We have our four complexes, right? Complex 1, 2, 3, and 4. Right. And then here, in between complex 1 and 2 is CoQ, or coenzyme Q. In between 2 and 3 is cytochrome C. I forget who was here. But anyways, NADH donates 2 hydrogens to this right here. This is NAD. In here is NAD plus. Out here, still NADH. So 2 of the hydroniums go into complex. Well, 2 of the electrons go into complex 1, and then out pumps how many? Hold on, let me remind myself. Out pumps something. It's how many of them get pumped out. The out pumps 2 hydroniums. Okay. The 2 electrons, the NAD donated, they go here, right? The little E's. They go here. Coenzyme Q then transfer this to to complex 2. In complex 2, it waits until they have 4 electrons. When they have 4 electrons, right? So this has to do this enough times for it to have 4 electrons. Once it has 4, it transfers these 4 electrons to complex 3. Right? That's literally all that's happening in complex 2. It is just transporting electrons from one side to the other. Right? Cool. Now, let's figure out what's happening in 3. Okay, boom. 3, we have hydrogen and we have oxygen. Okay. Hydrogen and oxygen are here. We are giving them electrons. These electrons, they flow here. 4 electrons, okay? 4 electrons are flowing where all of these free oxygens and hydrogens are chilling out. They're chilling, they're minding their business, and here come, these electrons trying to get them. They trying to get them. That's all they do. Cool. So they
in molecules
then hang up and they make H2O. They make a baby. It's H2O. Okay, that H2O stays in the matrix, right? I think. But this is all just in theory because I'm still learning it again for the 15th time in my life. Then in here we also have ATP. Well, not ATP. Sorry, it's not ATP yet. It's ADP. ADP plus the PI, which is just the extra phosphate. Yes, the extra phosphate. I think. Again, in theory, don't take my word for it. I'm still learning. They come here to complex 4, right? And they take all of these extra hydroniums here that we've just been letting hang out. They take all of those, and then this goes into oxidative phosphorylation. That makes a little sense. That makes a little sense. I think. Okay, what did I write over here? Right. So at complex 3, we're also once we get our hydrogens, we are pumping out for. I mean, get our electrons. We're pumping out for. Uh, what's it called? In here, we're also pumping out to. Ignore my handwriting is horrendous. I'm sorry. I'm trying. I'm trying to be better too. Something like that, right? I'm. I'm. I'm figuring it out. Hold on. All right. So that's citric acid, oxidative phosphorus. So hormone levels that goes in. Yo, is the electron transport chain even on the MCAT? The heck? I see the pentose pathway. I see glycolysis, glyconeogenesis, citric acid cycle, fatty acid metabolism, aka beta oxidation, and oxidative phosphorylation. It's like it's mentioned in terms of oxidative phosphorylation, not as a whole. But I mean, I guess we got the basics. All right. Let's get back to how we were. Let's get back to our studying setup, I guess. Yeah, I was like somewhere in there. Okay. 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 ADP to ATP. Yay. Let's go. All right. Okay. I'm sorry. Hmm. I should watch the video first before, because I'm going to confuse myself. Okay, there's no audio. That's great. Alright, let me see what's going on. We're at complex 4. Protons enter. As protons enter a component of alpha beta subunit.
Welcome to the next lesson in the Dirty Medicine Biochemistry series. In today's video, we're going to talk about something called oxidative phosphorylation. This is probably better known as the electron transport chain. When we left off, this is what we had discussed so far. Glucose can undergo glycolysis to become pyruvate. Pyruvate can also go back up to glucose through gluconeogenesis. Pyruvate can take one of 4 metabolic pathways. The most common destination for pyruvate is to be turned back into acetyl-CoA. Acetyl-CoA, everything that you need to know about the electron transport chain, including how it moves forward. To get started in this video, we need to design the electron transport chain so you have an image in your brain as to how this actually works. What you see here is the inner mitochondrial membrane in the middle of the slide. The bottom portion of the slide represents the mitochondrial matrix, and the top represents the intermembrane space. Now, along this inner mitochondrial membrane, we have a series of complexes, shown here in various colors. These complexes are numbered from 1 to 5. Complex 1 is shown in blue, complex 2 is shown in light pink, complex 3 in light green, complex 4...
I'm sorry, 1 to 5? What happened to the 4 complexes? Okay. Alright, come on.
in that peach color, and complex 5, which is better known as ATP synthase, is shown as the gray triangle on the far right. Additionally, you have the presence of 2 other molecules that act not as complexes, but they are embedded in this area of the electron transport chain. Those are coenzyme Q and cytochrome C. So CoQ and cytochrome C, shown there in the darker salmon color. Now, technically,
1, 2, 3, 4. And then I guess we need to add the other one as a fifth complex. Fifth complex.
Quickly, these are broken into two distinct parts of oxidative phosphorylation. The complex portion from 1 to 4, including CoQ and cytochrome C, is known as the electron transport chain, because this is where electrons get shuffled from one complex to the other. The ATP synthase, which pumps the proton gradient to generate ATP, and again we'll talk about that at the end of the video, is technically known as chemiosmosis. Now, it's the combination of the electron transport chain plus chemiosmosis that is together known as oxidative phosphorylation. That distinction is probably not important for the purposes of exams, but for keeping the big picture in mind, you should know that when somebody refers to oxidative phosphorylation, they're referring to this entire process. But when somebody refers to the electron transport chain, they're technically only talking about the movement of electrons from complexes 1 to 2 to 3 to 4 to oxygen. They're not.
Imagine being able to build anything just by thinking about it.
Final ATP synthase pump that generates the ATP. Now, how this works is a complexes exist in the membrane, and you have protons that are in the mitochondrial matrix. I told you that when we discussed the TCA cycle.
Okay. I'm gonna have to erase this. So down here, let me. Down here we have a bunch of. Oops. Bunch of hydroniums, and they're just floating around, minding their business. Okay, they all just they down in the matrix and they chilling.
ADH2 for use right here in the electron transport chain. So let's illustrate why those molecules are so important. So along comes NADH, and NADH approaches.
All right, so we got NADH down here.
Complex 1. NADH can give up its proton and give up its electrons and become NAD+. In the process, it donates its electrons to complex 1. When the electrons enter complex 1 gets supercharged, illustrated here with the yellow fuzzy border. When this complex gets supercharged, it has the energy to pump the proton from the mitochondrial matrix into the intermembrane space. As it does this, it pumps more and more protons from the mitochondrial matrix into the intermembrane space, and you get the accumulation of protons on the other side of the membrane.
Okay. NAD reduces to NAD plus over here at complex 1. Complex 1 is on Celsius, and it's literally taking up all of these like little hydroniums just floating around, and it's pumping them out this way. Out this way. So now we have the hydroniums out here. Right? The electron that NAD gave up, it gave to complex 1, which is why complex 1 is supercharged, and it can start pumping out hydroniums, right, out into the intermembrane space. Cool. Now,
this goes again from the mitochondrial matrix.
I feel like I understand this next part.
Is only made possible by the electron given up from NADH supercharging complex 1. Now, after a while, the electron is sitting complex 1, and the proton gradient is beginning to form. On the top, in the intermembrane space, you have much more protons than exist on the bottom in the mitochondrial matrix. Now, at this point, the gradient is beginning to form, and complex 1 will pass its electrons to CoQ. The electrons will go to CoQ and sit.
All right. I don't know where all of my stuff is at. So, over here at complex 2, right? Remember, this is 1, this is 2. Over here, we have CoQ. You can't even see that because I can barely see it, but we have CoQ. Oh, y'all can't see either. CoQ is taking the electrons that NAD gave here. Well, NADH gave here, right? It gave him electrons. It's now taking them, right? CoQ taking the little electrons and it's giving it to complex 2. That is the only thing the coenzyme Q does. It transfers the electrons from 1 to 2. Okay? That sounds reasonable. It's just a little transfer.
There, awaiting further instruction. Now at this point, FADH2 comes along and approaches complex 2.
It's also important to note that MCAT tests things like this, so it'll probably ask you about, I don't know, inhibitors. I don't know. When I buy UWorld, we'll figure it out. But it'll probably ask about inhibitors, right? So it's important to note that up here, there are more hydroniums than there are in here because of this supercharge right here, right? Which is why these electrons can no longer be here at 1, because 1 is going too crazy, it has to calm down. So it takes that electron, moves it to 2, and now he's calmed down a little bit, which makes me think that hydronium was going to be pumped back in at some point in time. Hold on.
Just like NADH, FADH2 was produced in the TCA cycle. It migrates here and begins its important role. FADH2 can give up its electrons and turn into FAD. In this process, it donates its electrons to complex 2. Complex 2, however, cannot become supercharged and cannot pump protons from the mitochondrial matrix into the intermembrane space. So the electron sits in complex 2 and awaits further instruction and ultimately gets passed to CoQ. Now I want to pause for a second.
What's wrong with these burger buns?
Okay.
It is perfectly delicious.
Okay. I need to eat. But here, right here, at 2, we have FADH, which is going to be reduced to FAD plus. FADH is reduced to FAD plus. Right? So because of it, same thing that happened here. Because of this, we are getting another electron that needs to go to complex 2. However, complex 2 does not have the capability of pumping electrons or hydronium out into the intermembrane space. So what does it do? It then gives its electron to CoQ. Makes sense. CoQ is literally just transferring stuff. That makes sense. You know, I've studied this for years, and today it makes sense. Okay. CoQ has now a couple electrons, and it needs to do something. It needs to go to 3. So, somehow we got to get CoQ to go over here to complex 3. Right? Complex 3 and 4 are cytochromes. Right? Cytochrome C is the transfer from 3 to 4. If you're not in science, this is going to sound so complicated, and I apologize to my TikTok folks. I'm sorry. I apologize to y'all. I didn't take Chem Phys in high school, but did bio. Any tips? Are you in undergrad? Are you asking about Chem Phys tips in undergrad, or are you asking about it now in high school? Either way, the best tip that I could give for physics is to learn the formulas. If you learn the formulas in the units, you're like golden for physics. Gotcha. You're like golden for physics. For chemistry, it depends. Now in high school, okay. For physics, you need to learn your formulas and your units. That's like the best thing that I could say, because once you know what they're asking you in the units, you know, like what formulas to use. It's like a backwards way of knowing. And then for chemistry, girl, I don't even remember high school chemistry. I barely remember chemistry now. Oh god. Chemistry. Let me think. I'm trying to think about what's the best advice to give. Yeah, I don't really got none. Do y'all have chemistry advice over here in TikTok? Cause thank you, thank you. Just giving it up, just giving it up, and we'll take it. Anyways, what was we talking about? Your chemistry advice. Sorry. Um, for chemistry, I would say the same thing. Know the formulas. That's like a really big thing. Um, I'm trying to think what was in chemistry. What was in chemistry? Um, I'm trying to think about my high school chemistry so I could give you some actual advice. Cause I'm not about to tell you what undergrad chemistry looked like in yeah. Your reactions. Okay, so for chemistry, your no, you not doing AP doesn't really matter. It's not a big deal that you didn't do AP. I promise. If you do good in your undergrad chemistry, you'll be fine. You'll be fine. And also, whenever you choose your undergrad institution or wherever you want to go for undergrad, make sure you're always going to the tutoring in the office hours. Please. I'm telling you, it's going to save your life. Especially when you start getting confused. Because then you studying for an MCAT like me and don't got no office hours to go to. Alright. What was we doing? Oxidative phosphorylation. That's what we was doing. My lord. Alright. Cytochrome giving up its electrons is going to go to 3. 3 then needs to transfer electrons eventually to 4. 4 is going to pump them out at some point in time. And then it's this whole electron chain gradient and now NADH in ATP synthase has to take place in 5. Complex 5. It's really not another complex. But yeah, for chemistry, your reactions are super important. And then I think there's like atomic numbering and some other stuff. There's like some other like really basic things that you're going to go over in every chemistry class ever. And if you know those, you can build on that. Y'all, my YouTube video is not playing. Jesus don't want me to learn or something? Like, what's going on? I went to Norfolk State in Virginia. It's a HBCU in Virginia. What are you asking? What undergrad class I took? I took Gen Chem 1 and 2. Oh, it is playing, y'all. It was muted.
See, the electrons arrive, and then get passed to complex 4. At complex 4, the electrons enter it and supercharge it, just like we've seen in complex 3 and in complex 1. Once supercharged, complex 4 has enough energy to pump protons from the mitochondrial matrix.
Okay, well, yeah. That's all that's going on there. So boom. Here we are at 3, then at 4. We have cytochrome, cyto C is giving its electrons. CoQ is giving its electrons to complex 3. Complex 3 doesn't know what to do with him. It just tosses him over to complex 4. Complex 4 then takes the rest of these hydroniums, and it starts pumping them out. We now have enough energy over here to start oxidative phosphorylation, which is ATP synthesis. Makes sense. Makes sense.
The intermembrane space. Again, the proton gradient continues to form. Look at the top of the slide. The intermembrane space is laced with tons of positively charged protons. So there's a proton gradient compared to the mitochondrial matrix, which has fewer protons. At this point, complex 4 has the electron sitting inside of it, and it needs to pass to the final electron acceptor. The final electron acceptor is oxygen.
Nursing students, please tell me that you are not relying on reading this thing to study.
Ugh, come on, ads, come on.
The electrons are passed to oxygen, which splits into 2 oxygen ions, and protons are added, creating 2 water molecules. Let's pause for a second. It is incredibly high yield to understand that the final and ultimate electron acceptor in the electron transport chain is oxygen. And by accepting the electrons and accepting...
Okay. Over here, we have a bunch of oxygens, little O2s. They're chilling out. They need to take on some proteins. Okay? I'm sorry, I misspoke. Not proteins. They need to take on protons. Alright. So, they need to take on some of those, hydroniums.
Protons, 2 water molecules are formed. Everything that I just said in that sentence is incredibly important and high yield to keep in mind when you're taking exams. Look at the electron transport chain. Complex 1 and complex 2 pass their electrons to CoQ. CoQ pass their electrons to complex 3. Complex 3 pass their electrons to cytochrome C. Cytochrome C pass their electrons to complex 4. And complex 4 pass their electrons to the ultimate electron acceptor, oxygen, which split into 2 oxygen ions before forming 2 water molecules. Everything that I just said is the electron transport chain. And at this point, the electrons have been shuffled from one complex to the next, supercharging the square complexes that you see here, which are complexes 1, 3, and 4, to pump protons from the mitochondrial matrix into the intermembrane space. Now at this point, we've formed a massive proton gradient. There are so many protons in the intermembrane space, and so fewer protons in the mitochondrial matrix. Now it's at this point that ATP synthase comes into play. ATP synthase is going to make use of this proton gradient to generate massive amounts of ATP. So along comes the molecule ADP. And ADP wants to turn into ATP, which is a higher energy molecule that can be used to give energy throughout the body. But in order to catalyze this conversion, we have to put an energy source into this reaction, because you can't just go from a lower energy source, ADP, to a higher energy molecule, ATP, without some type of energy input. It's at this point that ATP synthase takes advantage of the proton gradient, which was being formed by complexes 1, 3, and 4. The protons will always want to flow down its gradient. That is to say, molecules in general like to flow from high energy states to low energy states to achieve equilibrium. So protons will flow from the intermembrane space down through ATP synthase back to the mitochondrial matrix, and when they do this, it is an energy input that catalyzes the conversion of ADP to ATP. That is how the energy is formed, and massive amounts of ATP are formed during that step because there's such a large proton gradient that can continuously flow downhill. Now, as those protons come across ATP synthase, they build back up on the mitochondrial matrix. So they're sitting in front of complexes 1, 3, and 4, ready to be pumped back up into the intermembrane space when 1, 3, and 4 get supercharged. As you can see, the cycle continues, and the electron transport chain can continue to churn out ATP so long as NADH and FADH2 are being shuffled from the TCA cycle to the electron transport chain to continue the flow of protons. Now, here's where we are at this point. That is how the electron transport chain works, and that's how electrons are shuffled along this membrane. Now, what's important for the purposes of exams, and what's very high yield to know, is what drugs and what molecules inhibit each of these steps. Now, I've drawn them here on the slide. Robenone inhibits complex 1. Antimycin inhibits complex 3. Cyanide and carbon monoxide inhibit complex 4 and cytochrome C. Oligomycin inhibits ATP synthase. An uncoupling agent, such as 2,4-DNP, uncouples the proton gradient and inhibits the proton gradient's ability to pump protons down through ATP synthase. These are 5 electron transport chain inhibitors, or 5 inhibitors of oxidative phosphorylation, that you absolutely need to memorize. Not only do you need to know them by name, but you need to know exactly where they inhibit the electron transport chain. Again, I'm including this.
Do y'all know that it is my actual job? I get paid every 2 weeks to run an assay that inhibits all of this stuff. I just gotta know where it inhibits at. Just gotta know.
Here in this discussion, because the purpose of the electron transport chain is to generate ATP. Now, we've already talked about glycolysis, about gluconeogenesis, about pyruvate metabolism, and about the TCA cycle. And at each point in these steps, you generate small amounts of ATP, but nothing compares to the massive amount of ATP generated in oxidative phosphorylation. Let's slow down, take a step back, and look at the big picture when we talk about how much ATP is generated at each step along the way. In glycolysis, you actually do form a small amount of ATP. Go back to the glycolysis video and look at the total net reaction. You do form 2 ATP. But you also form some NADH, and NADH can be used in the electron transport chain, as you've seen today. So from the ATP itself, in glycolysis, you net 2 ATP, but from the NADH that can go on to be used in the electron transport chain, that can turn into 3 to 5 ATP. Because again,
It's my last semester in university, which means
Oh
I'll
my
be using
goodness. All the ads.
electrons to go through the electron transport chain. In the NADH and the F. Now the TCA cycle produces 6 NADH and 2 FADH2. In one spin of the TCA cycle, it produces 3 NADH and 1 FADH2. But the TCA cycle always spins twice, so you multiply those numbers by 2 to get 6 NADH formed and 2 FADH2 formed. Now over the years, biochemists have figured out that for each NADH molecule, you can form 2.5 ATPs, and for each
Okay.
FADH2 molecule, you can form 1 CA cycle, and the 2 FADH2 formed can generate anywhere from 30 to 32 ATP. This is very high yield to know, and it just goes to show you that it's the oxidative phosphorylation step that produces the most amount of ATP, but that's only made possible by shuffling NADH and FADH2.
Okay. That wasn't bad. I'm sorry, that was bad. I should not lie to y'all. That was bad. All right. God, you spend your whole life studying something, and you pay to study for it. All right. Hold on, you said something. I'm trying to see. Hey, does having volunteering experience in high school help? Yes. Yes. Try to volunteer with things that you actually like. And make sure you are like very good with your volunteering as far as getting your hours. If your state has a lottery, you more than likely have some type of in Florida it's called Bright Futures. Up here in Tennessee, it's something. I don't know, but they will pay for like you to go to school or like your first 2 years at school or something like that. Try to do that. In Tennessee, they only have to have 8 hours. That was what I was told. In Florida, when I graduated high school, which wasn't all that long ago, it was 2020. So literally, we had to have 100. So get your hours, get good hours, make really good experiences, and like learn from your experiences. You can learn a lot from just volunteering. It depends on where you volunteer, what you're gonna learn, but it's always a learning experience, and you can always talk about it later. Especially if you think that medical school is going to be something for you, or even just professional school, you can always talk about it later. I talk about some of my experiences volunteering and my medical school application. So, or will talk about it. I hope that answered your question. Ah, the light died, y'all. You're welcome. Wow, that looks. I'm sorry, that looks terribly bright. I can't do that. Okay. UPC. Okay. All right. Let's do the practice questions. Am I prepared to be embarrassed? Absolutely. Absolutely. Let's see if we learned anything. Okay. Alright, DMP is an uncoupler of oxidative phosphorylation used as a weight loss agent in the 1930s, but reports of fatal overdoses led to the discontinuation in 1939. Didn't last long. Which of the following would likely contribute to adverse effects of individuals taking 2,4-DMP? Hey. Okay. Option choices are ATP levels in the mitochondria were greater than normal. Body temperature became elevated as a result of hypermetabolism. It was an uncoupler of oxidative phosphorylation, which is like the equivalent of oligomycin, right? Is that not it? Probably. Equivalent of oligomycin. Delivery of electrons to O2 was blocked. It's an uncoupler of oxidative phosphorylation. It's complex 5. So that is the standard. That's like oligomycin. The hydronium gradient across the inner mitochondrial membrane was greater than normal. Okay. The rate of the electron transport became abnormally low. I don't think it will be low, mainly because this is happening at the end of the cycle, right? So delivery of electrons to O2 can't be blocked because that's in 4, and this is happening in 5. Hydronium, no, was greater than normal. I don't. But that wouldn't be why people overdose. I don't think. I think the only symptom I'm seeing is the body heat, the body temperature. Hello. 30 seconds. Okay. Which of the following has the strongest tendency to gain electrons? Coenzyme Q, cytochrome C, Favlin or FAD, and then NAD. Sorry. And oxygen. Thank you. All right. Oh, that wasn't multiple choice. I was confused. What about them exactly? When you have dialysis, it means that your kidneys aren't filtering everything that they need to. Sorry, there we go. They aren't filtering everything that they need to, including oxygen, nitrogen, components of urea, which then creates urine. So what dialysis does is it is essentially a pump. Either you do it overnight. Some people, hello, don't end my live. Either you do it overnight, because some people do overnight dialysis and they do that every night, or you do it for about 2 hours, like 3 days a week. And you're essentially sitting there and having your kidneys like flushed and pumped, because it's doing the pumping motion that your kidneys should be doing, and filtering out your blood, filtering out all of that good stuff. That's the basis of dialysis. Is that it's essentially taking over the filtration system of the kidneys. Those things need to be filtered because they can be toxic in high amounts. So you can't just have a bunch of I'm blanking. You can't just have like a bunch of nitrogen and stuff floating around in the blood, because it'll just make. What about the nephrons? The nephrons are, so the kidney as a whole has a bunch of nephrons. The nephrons are like the kidney cells in a way. The nephrons, they're kind of like something like that. So, and you can't even see that. I'm so sorry. I need to get a different color. What? It looks like the blackish. Sorry, it looks like the blackish. So we have our little nephron. Okay. Components of a nephron. Over here, glomerulus. Glomerulus is what is taking in the all of, essentially where your blood is being. Ooh. I am so sorry for you. I am so sorry for you. Glomerulus. Here. A little filter duct. Everything that goes through here everything that goes through here is going through here in basically just by diffusion. It goes through here, it goes through the descending limb. Sorry, can't draw apparently. The descending limb. In this process, things are going in and out. It then comes over here to the ascending limb, going up, and things are being filtered out here as well. Then you get all the way up here, and you're doing out through the urethra. Well, it creates urea, and everything goes out through the urethra. That was not the best explanation, but that's only because I was just thinking about the electron transport chain for the last 2 hours, so I apologize. It's okay. Physiology is tomorrow. Yeah, so essentially when you need dialysis, something is not happening usually here. I do watch Dr. Mike from time to time. Usually it's not happening either here in the glomerulus or descending or ascending, right? Because this is where things are getting filtered. No, not an exam. I'm just studying. This is where things are getting filtered. Here, and here. When something is not happening there, you end up with a surplus of usually something that the body does not need a surplus of. And that is why you need dialysis. What dialysis does is it takes all of the things that need to be pumped out, so like nitrogen and urea and all of that stuff. It pumps all of that out and filters your blood. Essentially, like if you've ever like gotten a feel of like a bypass surgery, like a cardiac bypass surgery, where they are pumping your blood still, even though your heart is not technically in your body, because they're pumping and they're doing like a heart transplant, or they're doing something on the heart where they need to stop the heart from beating. Same kind of thing with the kidneys, except the kidneys don't have to be removed for that. But they still go in and like filter your blood. Is that making sense? I hope that makes sense. What was I going to do tomorrow? I feel like it was like behavioral and like physiology. Let me go to my calendar. Google calendar. Okay, it does make sense. Cardiac arrest. Couple things there. Usually in cardiac arrest, it means it can mean a few things. It can mean a few things. One, there could be a blood clot. I'm sorry, I'm pulling up my calendar. I'm trying to see. Where is? Where is? Where's my calendar? Okay, here we go. Calendar. I'm sorry. What did you say? Funny story. So, I again in a nursing home, you have like dementia patients, right? These dementia patients, they're interesting. They're interesting for sure. We had a guy who was on hospice, and I don't even know if he was Catholic, but he thought that he was about to die right then and there, and started like reciting the Catholic prayer or whatever the Catholic prayer. What happened? Or what he started to try to recite the Catholic prayer. I'm not Catholic, so I don't actually know it. But we were in there with him and we were trying to be supportive. And he forgot the Catholic prayer because he has dementia. So he got like a quarter of the way through it and was like, "Oh shit, I forgot what's the rest of it." I don't know. I'm Baptist. How am I supposed to help you? I don't know. I am Baptist. I don't know the rest of it. And he was like holding on to a rosemary and everything. I'm like, I really don't know. I'm trying to be supportive here, but I don't know. Oh my god, he was a mess. He would always try to get up and walk knowing that he couldn't. Yeah. He was a mess. He was a mess. Oh goodness. There was a time that we had 3 codes in one night though. I got in all 10,000 steps. Probably like 12,000. Like the way our building was split up, there was 3 wings, and I kid you not, they called a code blue on all 3 wings. It was like everybody was trying to get up out of there. Everybody was trying to get up out of there. It was crazy. It was crazy. I don't know what I don't know why it had to be my night that I was working. Everybody want to die on me. No. You're not allowed. That's against the rules. It's actually against the rules. You can't do that. We're not doing that. Not tonight. No, I've never experienced that. I've never experienced that. I've never had a black, silver, pink. Like we would have practice drills and stuff, but I never had a black, silver, or pink. We did have a red, which means fire. We did have it wasn't like it was in the kitchen. Um um what's the other one? We had one for inclement weather. I think that's purple. Or at least it was purple. It was purple when I was in primary care. working in the clinic, I think. We had that. As far as working there, were there people my age working there? I was 18, so no. No, there were not people necessarily my age working there. I think I was the youngest person there, period. I'm usually the youngest person anywhere I go. So, I was 18 at the time. There was nobody there my age. But I did it's not like it was a crazy age difference. They were usually like 21 or something. It was usually like 20, 21. But I was the youngest person there. I was like 18. Worst story. Oh, you're asking about the patients. No, they're not all old. There were nobody, again, I was 18, so there was nobody my age there. But, of course, you have, like, your older people in the nursing home, but then you have, like, you have people that are just there. Like, there was a guy that got in a car accident, and he just needed the rehab, and, like, his insurance is paying for him to have rehab in a nursing home versus at home, mainly because I think he lived by himself, so it was going to be, like, he was going to have, like, in-house nurse, like, 24/7, because he basically had to learn how to walk again, so, the safest choice was to just be in a rehab facility or, like, a nursing home. Some of them are. I had mostly pleasant experiences. There were some people. There was this guy. This wasn't a nursing home. This was primary care when I was in the clinic with doctors and whatnot. Oh, my associates and my bachelors. There was this guy, and he. My master's is on my piano that I don't play. There was this guy in primary care, and he literally, I could not stand when he came in. One, because he always wanted to keep the door open, and I was like, you can't just do that. Like, this is a very, very, very public clinic. If we ever got, like, somebody came by and had heard us having a whole conversation about your health and all types of HIPAA laws, that will be broken. And he wasn't a quiet guy. He was talking loud. And he couldn't hear, so you also had to talk loud. You can't really do that with the door open. No, he was a patient, and he was always rude. he had his little motorized scooter. It is. Some people get claustrophobic in rooms, though. So usually we leave them, if it's like that, we'll put them in a separate room, like, further away. But also, at the same time, you can't just be talking loud, you know? But yeah, he was a mess. He had a bunch of problems with him. He was non-compliant with his medication. I mean, like, not taking it at all. And we were like, dude, Mr. So-and-so, you need to take your meds, because you're going to die without them. And eventually he did. That was that. I don't like people telling me what to do. Sorry. Also, nurses be around here getting milli-whopped. I can't do that. I am 5'1" on a good day. But seriously, no. It was like me having the like, wanting to essentially be in control, and eventually I do want my own clinic. It'll be something. I want a rheumatology clinic in, like, some, backwoods area. But I shouldn't say backwoods. Like, I don't want to stay in the city. I'm a country girl at heart, so I want to be probably like middle Georgia. honestly. But also Georgia is very, very red, so I don't know. But anyways, I want to provide rheumatology care in areas that probably don't have rheumatologists, or probably people that have never seen a rheumatologist. And I want to do that, which is why I also want to do med peds, so I can treat adult and pediatric rheumatology. Because when I needed a rheumatologist, there wasn't anyone in 30 miles of me. So there was that. There was that. If I didn't go to a different county, I could be dead. Or with, I could be dead, or I could have had kidney failure. There's a bunch of stuff that could have happened if I hadn't gone to Orlando. A bunch of stuff that didn't happen. I did not. I did not. I actually only had a roommate my first semester of college. We were in, it was like a suite, so there was 3 rooms, and everybody had one roommate. But no, I've never had a crazy roommate. She was great, and yeah. After that, I started staying by myself though. But it wasn't because of any experience. It was just because I had the option to, so I stayed by myself. Yeah, no advice there. No advice there. Once you find out who your roommate is, try to like talk to them and get to know them. Are y'all applying to school this year? Mine wasn't. Mine wasn't. It was probably the size of my current room. The only thing is, it depends on the school, but yes. The only thing is, in it, you have to do your housing application early in order to do that. Only thing is, there were 2 people in the, like, think of the size of, a decent sized bedroom, and then, gotcha. Think of a size of a decent sized bedroom, and then just put 2 people in there. That's what it is. Now that's if there is 2 people. Some people do 3 people. The rooms are bigger when you have to do 3 people, but it kind of, it just depends. That's my answer. It depends. Sitting for the SAT. Okay. I think I sat for the SAT. I think I sat for the SAT like 3 times. I went to a HBCU, so yes. I can't say how well the I don't know. I don't know if it's cheaper. I can't say how well the food is at other places, but at my undergrad, it was good. You know, it was good. I don't know if it's cheaper though. I know that certain dorms are cheaper. If you go to a HBCU, homecoming will be a abundance of crazy stories that I will not tell on the internet. I'm sorry. Um, Let me think. I don't think I had a bunch of crazy college stories. At least not the ones that I would tell. Yeah, no, not the ones that I would tell. Prison food. I was getting a. They gave me a whole leg quarter. High school stories. Interesting. Ugh. I'm trying to remember high school. Hmm. This camera is about to die. High school stories. There was a bunch of stuff going on. There's like 3 people that had like kids in high school. I remember that distinctly. Um, let's see. After we graduated, there was a shooting, and my cousin got killed, and it was at a graduation party. Um, no, literally a whole leg quarter. And they gave me like a whole big thing of like collard greens. Like, again, this was a HBCU, so it was like soul food, and they gave me, when we had fried fish, it was like, it was a fat sandwich. It was a fat sandwich because that piece of fish was long and thick. Let's see. I don't know if there's like anything that I remember. I would have to talk to people from high school. Oh, this camera's dying. All right, y'all. I have to go. I will talk to y'all later. Remember to like, comment, and subscribe. Continue to ask me questions. I will get to them and answer them. All right. Bye. Okay.